Nice to meet you. I'm Khushal Choktai and you're watching my YouTube channel, School of Advanced Chemistry. I'm going to explain May June 23 paper 5 2 variant, 5-2 variant. Let's get started. Question number 2, pure water dissociates according to the equation shown over here. This is the dissociation of water. H2O is going to dissociate into H positive ion and OH negative ion. The equilibrium constant for this reaction is known as Kw, the ionic product of the water, that is Kw I mean, and this is the expression of Kw. At 25 degrees Celsius, Kw has the value of 1 into 10 to the power minus 14 moles square dm minus 6. The pH of the pure water at 25 degrees Celsius is 7. A student finds the pH of the pure water at 35 degrees Celsius is 6.84. The student investigates how the temperature affects the pH of the pure water and determine the value of enthalpy change of dissociation of water, delta H for the dissociation of water. Student records the pH of the pure water at different temperatures. A line for the best fit from the result of the student's investigation is shown in figure 2.1. Here is this figure. Now come to the next one. Part A1, use the figure 2.1 to calculate the hydrogen ion concentration of the pure water at 45 degrees Celsius, and the formula of the pH is given over here, that is minus log of H positive ion concentration. So I'm going to use this graph. First of all, with the help of this graph, I can find the pH versus temperature. You can see that here is the temperature, here is the pH, and here is the 45 degrees Celsius temperature. In front of 45, this is the line. And here we can see that what is the value of the pH, that is 6.70 is the pH. So pH, first of all, I'm going to find the pH, and pH is equal to 6.70 with the help of this curve, this figure. Now, how to find the concentration of H positive ion with the help of pH? The shortcut, the basic formula is H positive ion concentration is equal to 10 raised to power minus pH. And here 10 raised to power minus 6.7 into 6.70. And here it's 10 raised to power minus 6.70. And this answer is the concentration of hydrogen ion. 2 into 10 raised to power minus 7 is the concentration of H positive ion. Next is calculate the value of Kw for the pure water at 40 degrees Celsius. So the formula of the Kw is given over here, this one. And I'm going to put the value of H positive ion and OH negative ion as well to find the answer of this Kw. So the basic theme is the concentration of H positive ion is also equal to the concentration of OH negative ion. So they both, in this case, they both are equal. So when the water is going to dissociate, then at that time, this formula holds good, and the concentration of these both ion is going to be same. When we are going to dissociate a water into the molecule, then same concentration or same quantity of OH and H positive ions are being formed. So that is why both concentration of H positive ion and OH negative ion from the water will be the same. So Kw is equal to 2 into 10 raised to power minus 7 square. And here will be the answer of Kw at 45 degrees Celsius. And the answer is 3.9 0.98 into 10 to the power minus 14. Next portion state the relationship between Kw and temperature. So as you have seen that as we are going to heat the water, its ionization extent will be increased. I mean, that is the new answer of Kw at higher temperature, and this answer was at 25 degrees Celsius. So finally, we can conclude that the value of Kw increases as the temperature increases. Value of Kw increases as the temperature increases. Next one, a student determines the Kw at the range of temperature. The results are shown in table 2.1. Table 2.1 temperature, and here is the 1 over T Kw log Kw and so on. Now here are the two columns, and I think he is asking to convert this temperature into inverse temperature. So it's simple, it's not very difficult. And yes, complete the table 2.1, record 1 over T to the three significant figures using the standard form, record log Kw to two decimal places, and that is of 2 marks. Then the next one is plot the graph. So first one, I'm going to fill it. I'm going to complete it. So 1 by these temperature will be the answer of 1 over T. And the answer is, so these are the answer of 1 over K, temperature inverse. Same is the case, the answer of log Kw, and here is the answer of log Kw. Plot the graph on the grid to show relationship between Kw and 1 over T to use across to plot each data. Draw a line of the best fit and so on. Then he is asking to draw the circle, the one point on the graph that you consider to be the most anomalous. Suggest one reason to explain anomalous point you have circled. Assume there were no error in determining Kw and so on. So first of all, I'm going to draw this curve. The relationship between Kw and 1 over T is given by this equation shown over here. And use the gradient, determine BV and BV to calculate the value of enthalpy change in kilojoules per mole and further dissociation of water delta H. If you were unable to determine the value of gradient, then use this value and so on. First of all, I'm going to find the gradient. So gradient, I mean, I can take any 2 point on the straight line, and then I can find its gradient. And its gradient will be, if I'm taking this whole triangle, I mean, the whole curve, the whole graph. So the final answer is 3.57. And what is the answer over here? It will be equal to 12.38. So if I'm just taking these two answers, so the value of the y-axis is equal to 12.38 minus 12.38 minus, what was this initial point, 14.6, and divided by minus, I mean, and here is 3.57 minus 2.8. So here is the answer of this whole sum, and that is equal to minus 12.38 plus 14.6 divided by 3.57 minus 2.8. So that's equal to 2.2 divided by 77. Part 4. Suggest one reason to explain the anomalous point you have circled. Assume that there was no error in determining the KW. Here you can see that this is anomalous point, and if it is on the line, then it may be at this position, or it may or might be at this position. So here seeing that there is no error along the determination of KW. So vertical error is not possible. So here is the error. Error is lying over here. I mean, this spot originally should be located over here. So that is because of the wrong temperature measurement. And here, I mean, temperature was measured too early. So originally it should be over here, and that is at high temperature. This spot is at low temperature. At low temperature, the spot was taken or measured. So basically, five, use your graph to determine the gradient of the line of the best fit. State the coordinate of the both points you used in your calculation. These must be selected from your line of the best fit, coordinate 1 and coordinates 2. So coordinate 1, I mean, there are the two coordinate on this line, on this section. Here, the one coordinate is minus 12.38, and other one, its coordinate is minus 14.6. That is over here. So two coordinates, two y coordinates, and two x coordinates. So two y coordinates, as I told you, minus 12.38, minus 12.38, and minus 14.6. Coordinates 2, that is with respect to the y-axis, the which one is 2.8 for this line that is intersecting the y-axis, 2.8. The last one is 3.57. 2.8 and 3.57. So these are the two x coordinate. So now he is asking to find the gradient, and as I have calculated over there, that is equal to 2.85. I mean y2 minus y1 over x2 minus x1, that is the gradient, and here it is 2.85. So that is the answer of this gradient. You can see that this is the equation of straight line. I mean, I'm taking this on y-axis and here 1 over t on x-axis. So this value will be said to be will be the slope of this curve. So the answer of the slope, that is 2.85. 2.85 is equal to delta H part 6.